Okay, so let's have a look at this question. So we've got the graph, so this is a rational, but the problem with this is it's not in the form that we would like. It's not in the y equals a over x minus h plus k form. It has a polynomial here instead of a. We need to first do polynomial division on this to get it into this form. So we'll set it up. We'll put our denominator out here, and then our numerator over here. And now our thought process. Do you guys remember how to do this? How many times does x go into 3x? 3 times. Okay? 3 times x is 3x. 3 times minus 2 is negative 6. Now we're subtracting down. 3x subtract 3x is 0. Negative 4 subtract negative 6. So negative 4 minus 6 is 2. All right. And that's our remainder. So it goes in 3 whole times. And this is our remainder. So we could write y equals 3x minus 4 over x minus 2. Or we could write y equals 3 plus, and then 2 is our remainder, right? And so we write it over this. Okay? Over the x minus 2. So it went in 3 whole times. And then 2 was our remainder of that x minus 2. So 3 would be k. So y equals 2 over x minus 2 plus 3. So our remainder is the a value. And our k value is how many whole times it went in. All right, does that kind of make sense? Yes, no? May? Okay, so if we remember the division that we were doing, we were just simply doing this, right? And then we would write this plus this over this. It's exactly what we're doing now. It's exactly what I did here, but now all I did was I just wrote it in the reverse order. I just switched the 2 around so that the rational function part, the rational comes first, and then the k part comes second. So I just switched the order here. Okay? All right. Now, everything else that comes after is exactly what we did before. So now I'm going to graph y equals 2 over x minus 2 plus 3. So basically we're taking our base graph of 1 over x and we're moving it right 2 and up 3. So I'm going to have an asymptote at 3 and at 2. So I've got my y equals 3, x equals 2. So my non-permissible value, x equals 2. My vertical asymptote, x equals 2. My horizontal asymptote, y equals 3. My domain, x can't be 2. And my range, y equals 3. all that I can fill out all together. The only thing I really need to do now is figure out my x and y intercept. And so the procedure for that doesn't change at all. How do I figure out my x-intercept? Set y equals 0. How do I figure out my did I say that the wrong order first? How do I figure out my x-intercept? Set y equals 0. How do I figure out my y-intercept? Set x equal to 0. So what do we get when x is equal to 0? I get -1 plus 3, so that's 2. And what do I get when y is 0? I get 4/3. So that's the same as 1 1/3. So I need 2 nice points. I should have a nice point on each quadrant. There's a problem. Now, right here, what do you notice where my points are? They're both in the same quadrant, right? So I need to figure out another point. So now I need to choose a point that's going to end up giving me a value over here in this quadrant. So what would be a good choice of an x value to give me another point here? 3? Okay, so choose x equals 3, and then what does that give me for a y value? Y equals 5. Okay, so now you have to make sure that you have, so just because it didn't automatically give it to you over here doesn't mean that it doesn't exist here. You have to know that it exists in 2 quadrants, and you have to find that, okay? All right. So end behavior, same idea again. Explain the end behavior near the graph, near the non-permissible values. So the non-permissible value of y equals 3, so that's over here. So what's happening? So the x values are getting, the absolute value of the x values are getting extremely large as they approach the asymptote there. And over here, at x equals 2, the absolute value of the y's are getting extremely large as they approach that asymptote as well. Okay. All right. So the last example is similar to the one that I just did. So I'm not going to do it here. I want you guys to do it, and then I'll come around and check it. Sound good? Okay.